Good morning. Okay, so
Good morning, sir.
good morning. Good morning, all.
Yes.
Good morning, sir.
Good morning. Okay, so today we will start DIF FFT algorithm. Before that, I would like to discuss few things that what essentially we are going to do. Now, you know that FFT algorithm, the purpose of doing FFT algorithm is to reduce the computational complexity of discrete Fourier transform or DFT. Okay. Now, this is done by decreasing the value of n. What do I mean by that? If I have 8-point DFT, then I will not compute DFT or DFT until we come to 2-point DFT. Until we come into 2-point DFT, we don't compute. Therefore, the larger sequence is divided into smaller sequence, and subsequently we have seen that if we reduce the n while computation of DFT, then this reduces computational complexity to a great extent. That we have seen. Okay, so main purpose of FFT algorithm is to reduce the computational complexity, and computational complexity could be reduced if I reduce the n-point DFT to n by 2-point DFT and n by 4-point DFT until we come into 2-point DFT. Once we come into 2-point DFT, then we will compute DFT, and this process will reduce computational complexity to a great extent. This is what is the underlying feature of this algorithm or studying this topic as well. Now in DIT-FFT, what we have seen that if I have original xn, xk is an n-point DFT, then xn is divided into two signal, that is f1 of n, f2 of n, correspondingly f1 of k, f2 of k are the DFT. This is n by 2 point. Now this f1 of n again divided into two parts, that is v11 of n and v12 of n, f2 of n again divided into two parts, v21 of n and v22 of n. Corresponding DFTs are B21 of K, B22 of K, B11 of K, and B12 of K. They are all n bar 4-point DFT. So this was the flow of the algorithm DIT-FFT. So X of n, 2 signals, then again 2 signals. So therefore, in this, what we have observed that whatever calculation we have carried out, the purpose was that X of n is divided on the basis of odd and even sequence. X of n sequence is divided on the basis of odd and even, and this decimation or division that takes place in time domain, that's why this is called DIT, decimation in time. And reduction process from n to n by 2 up to n by 4 until we come into a sequence of 2 points. This process is called faster Fourier transform algorithmic approach. Essentially, it reduces computational complexity. This was the DIT-FFT in summarization. This whole thing summarizes the whole DIT-FFT algorithm. Now moving ahead with the DIF-FFT algorithm, decimation in frequency. Frequency is also discrete, right? In DIF, I mean in DFT or FFT, whatever you call, frequency is also discrete. This is the difference DFT and DTFT. DTFT and DFT, this is the difference, that DTFT frequency domain, that is continuous, even though time domain discrete, that is DTFT. But DFT or FFT, they are both discrete in continuous, both discrete in time and frequency. So DFT or FFT is discrete both time and frequency. So this is the major advantage of DFT or FFT. Now, decimation in frequency approach. Previous approach is decimation in time approach. So whatever operation essentially we have done on the basis of xn, that is decimation in time. Now coming back to decimation in frequency approach, this division, odd, even, and everything will be carried out on frequency. That means x of k will divide into 2 parts. X of k is n-point DFT. I'll divide in 2 parts, g1 of k, g2 of k. Corresponding time domain is supposed to g1n and g2n, but we will divide x of k into 2 parts. Since this is x of k is essentially a discrete frequency. K is essentially a discrete frequency, and k will take value 0 to n minus 1. Here k will take value 0 to n by 2 minus 1. Here k will take value 0 to n by 4 minus 1. But the point is, here this division or decimation that carried out in frequency domain. Once this is carried out in frequency domain, that is called decimation in frequency reduced to first Fourier transform, right? First Fourier transform because of reduced computational complexity, because you are computing it in lower point and then combining together to get higher point DFT. In this process, the computational complexity reduces, and therefore DFT becomes FFT. However, the point is DIF comes from this, that is x of k, that is divided into 2, g1 of k, g2 of k, and g1 of k again divided into g1 of k and g1 2 of k. Now g1 of k is n by 2 point, g2 of k n by 2 point, this is n point, and d11 of k, d12 of k, d21 of k, d22 of k, they are n by 4 points. Of course, they will have their time domain counterpart or time domain part also there, but essentially we are dividing on the basis of frequency. Of course, they are having the inverse, like g1 and g2 of n, they are having 4 points if it is n. If n is equal to 8, then g1, g2 will be 4 point, and d1, d2, d21, d22, k, they will be having 2 points because it is n by 4 points. So basically, by looking into the approach, fundamental concept remains same. What do I mean? I mean that FFT essentially reduces the computational complexity. That part will remain as it is in DIT as well as DIF. Only difference is in decimation in time, the odd even operation or decomposition or decimation in DIT carried out in time domain, and in DIF that decimation or decomposition of odd even that is carried out in frequency domain in case of DIF. This is the two fundamental difference, and that gives the skeleton of the two algorithm. By nature, what is the difference? Agreed? Any doubt in that? No doubt. No doubt.
ফার্স্ট পয়েন্টে কি বলেন?
First one,
ফার্স্ট পয়েন্টে কি বলেন?
first point is that if I say two DFT, one is DFT and FFT. Difference is DIT is a higher computational complexity, FFT is having lesser computational complexity. This is the difference between DFT and FFT. However, result of DFT, result of FFT same. Now, if I now come into the two algorithm, DIT FFT and DIF FFT, both are FFT. Therefore, computational complexity reduction is the major target of these two algorithms. Now, in decimation in time, decomposition or decimation of odd and even counterpart that is carried out in time domain, that is DIT, and if the decomposition or decimation that is carried out in frequency domain, then it is DIF, right? So carrying out the decimation or decomposition, that actually distinguishes these two algorithms. However, purpose of this algorithm or target of this algorithm is same, is to reduce the computational complexity, right? And reduction of computational complexity that is achieved by reducing the number of points in the DFT when we are calculating the DFT. Once we calculate the DFT in lower point, then we combine those results to get the higher point DFT. In the process, computational complexity gets reduced. Agreed? Any doubt? No doubt. I think the philosophy of the algorithm now very much clear. What is the target and what is the difference between these two algorithms, that we have understood. What is the similarity between these two algorithms, that is also we have understood. Okay. Now let us move into, I have already completed DIT FFT algorithm in detail. We have taken 4 classes on that. So DIF FFT, I would like to take up the next thing. So with keeping in mind that whatever decimation or decomposition we will carry out in this particular algorithm, that will be on the basis of frequency, discrete frequency, which is denoted by K. Agreed? Fine. Okay, now DIF FFT, decimation in frequency, radix to FFT algorithm. Now see, x of k, n equal to 0 to n minus 1, x of n, wn, kn. This is the basic equation of DFT. This is known as n point DFT because this is n, wn. And also your x of n, that is the length of the signal, has to be less than equal to n. That is less than equal to n because to avoid frequency aliasing. We have discussed this already, that if we take more than that, then there will be frequency aliasing. Okay. Therefore, first this n is finalized, then this limit is fixed. This is the maximum possible limit of xn. All right. Do you agree with that?
Yes, sir.
Very good. Now let us do that. How do I do that in decomposition in frequency domain? So I am writing x of k. Try to understand this step very carefully because there is certain difficulties in this. Let us try to understand this. Now I am dividing into two parts, like n equal to 0 to n by 2 minus 1. This is 0 to n minus 1. Now next part will be n by 2 to n minus 1. X of n, W and K. So I am dividing it into first two different summation. Two different summation means these two add together, you should get this summation. So I'm writing 0 to n by 2 minus 1, x of n, W and K n equal to n by 2 to n minus 1, x of n, W and K n. That is your x of k. These two lines are same. Agreed?
Yes, sir.
Fine. Now, n equal to 0 to n minus 2, this part remains same. Now I'm writing this particular term. I am writing n equal to 0 to n by 2 minus 1, x of n plus n by 2, W and K into n plus n by 2. Is it okay? This step to this step. Okay. See,
Yes, sir.
now if everybody understood, then it's okay. But since still I would like to explain. If you have understood, still I would like to explain a little bit again. Let me explain. Suppose if I put n equal to n by 2, what is the term? First term. This summation starts from n equal to n by 2 that goes up to n into n minus 1. So first term will be x of n by 2 W and K into n by 2, right? First term of the summation.
Yes, sir.
Agreed. Very good. So now if I substitute n equal to 0, this is also first term will be x of n by 2 W and K into n by 2. So these two terms remain same.
Yes.
Right. Here if you put n equal to n by 2, whatever you result you will get from this particular section. If I put n equal to 0 here, these two results are identical.
Yes, sir.
Yes. Similarly, if I substitute n minus 1, that will be x of n minus 1 W and K n minus 1. Let us suppose n by 2 minus 1, if you substitute, that will be x of n minus 1. If we have to do n by 2 minus 1, this will be x of n minus 1. So first term and last term remain same. Therefore, all individual terms in between, that will also remain same. What I understand. Therefore, these two terms are identical. Okay. Now, what is the purpose of doing this? The purpose of doing this conversion from this to this step is we have to add these two summation, because now they are having the identical limit. If the limits are identical and the variable remains same, then we can always add two summation. Very important point. This is mathematical point of view, that if the variables remain same, right, and the limits are also remain same, then we can always add these two content of the summation. Okay, so this is also the varying over n, this is varying over n, and they are having an identical summation, so we can add this together. Now this we can add. Now here we have a little manipulation from this step to this step. Suppose n equal to n by 2 minus 1, x of n plus n by 2, then W and K n corresponding to this term. Next term is W and K n by 2. If you now calculate this W and K n by 2, so e to the power j 2 pi by n into K times n by 2, e to the power minus j pi K, e to the power minus j pi K equal to minus 1 to the power K. Is it all right?
Yes.
Yes, sir.
Very good. Very good. So this term, if I adjust now, x of n plus minus 1 to the power k, x of n plus n by 2, W n K n. Agreed? This total thing I have adjusted. X of n plus x of n plus n by 2, W n K n. This is actually W n K n is common in both the cases. So x of n plus x of n by 2 minus 1 to the power k. This will give you n equal to 0 to n minus 1. This is the expression that I have derived starting from x of n. Okay. So
স্যার এই সামেশনের পার্টটা আবার রিপিট করবেন?
এইটা
হ্যাঁ স্যার, n-1 থেকে n/2 -1 টা। হ্যাঁ
এইটা দেখো,
হ্যাঁ
suppose if we take the first value x equal to n by 2, if I substitute x equal to n by 2, it becomes x of capital N by 2 W n K into n by 2. This is the first term of the summation. Okay. Now if we put n equal to 0 here, n equal to 0 here, then again also x of n by 2 W n K n by 2. These two terms remain same. Here if you
Yes, sir.
substitute n by 2, whatever you get, here it if you substitute 0, whatever you get, if they are identical. Yes. Similarly, if you substitute n minus 1 here, x of n minus 1, wn k times n equal to n minus 1. Now, if you substitute n by 2 minus 1 here, well, this will be n by 2 minus 1. So, n by 2 plus n by 2, n by n, n minus 1. Wn k, if I write n by 2 minus 1, so n by 2 plus n by 2, n minus 1. So, last term also remains same. Okay. So, if you substitute n minus 1, whatever you will get, if you substitute n by 2 minus 1 here, whatever you will get, that will remain same. So, we'll check for first term and last term. If these two are identical, then I will assume the terms in between 0 to n by 2 minus 1, that will remain identical. Okay, this is the argument that I have developed. That if I check that two summation, the first term and last term are same, therefore I will assume that term in between there also will remain identical. Agreed? So I hope
Yes, sir.
this part to this part is okay.
Yes, sir.
Very good. Anyway, I said that this part is actually a real understanding. This part actually you have to be very clear. That's what I have said in the beginning, that this mathematical manipulation you have to understand. Okay. Once you understand this, probably this algorithm, most of the part is over. Very good. Now, this is x of k. This is your x of k, because this is x of k I am writing. So, this is x of k definitely. Now, I am writing that x of k, k even. Now, it is x of 2k. I said that this is decimation in frequency algorithm. So, whatever decimation, decomposition, whatever you term it, that will be carried out in frequency domain. And another important thing, when I am writing x of 2k, that means I am taking only even parts. So, previously that was equal to 0 to n minus 1, that limit is k here. Here k is 0 to n minus 1, because this is an endpoint DFT. This is endpoint DFT because this is n, and this is 0 to n minus 1. This is endpoint DFT because this is n, and this is 0 to n minus 1. This 0 to n minus 1, that denotes the maximum length of the sequence, or maximum permissible length of the sequence. Rather, maximum permissible length of the sequence, that is equal to n. Agreed? Therefore, if we move forward, then x of k, k even, that will give you x of 2k. X of 2k, if you write, means we are taking the even parts of x of k. Right? If you take the even parts and odd part and they are distributed, then this k value will be 0, 1 to n by 2 minus 1. Right? If x of k having n points, then if you take only even points, then it will be n by 2 minus 1. Okay? Very good. For example, okay, I will come to example later part. Okay, first you understand. I hope this you can understand, because previously we have seen when x of n to f1 of n, f1 of n equal to x of 2n, f2 of n, x of 2n plus 1, f2 of n, that we have discussed. Then you have seen that if your x of n 8 point, they are 4 distributed. Right? Therefore, it is n by 2 minus 1. Right? If it is 0 to 7 means n by 2 minus 1 means what? 7 by 2. I mean, how many will be n by n equal to 8? 8 by 2 minus 1. Is not it? So 8 by 2 minus 1 means it will be 4 minus 1 means 0 to 3. Previously, we have seen this in decimation in time algorithm. Now, here also x of k having n points. Then if we divide it into two parts, then x of 2k, that will contain k equal to 0, 1 to n by 2 minus 1. I hope this is okay.
Yes.
Fine. Now, x of 2k means I will substitute k equal to 2, k equal to 2 here. K equal to 2 here means x of n minus 1 to the power 2k, x of n plus n by 2, wn 2kn. In place of k, I will write 2k in this particular expression, because this is the expression for x of k. Agreed? This is the expression for x of k.
Yes.
Then if you want to find 2k, I will replace k by 2k. Then this will be minus 1 to the power 2k, and this will be equal to 2kn. This expression will be x of k, k even, or x of 2k. Agreed? Fine. I hope it's all right. Good. Now,
Yes.
now this part to this line, then minus 1 to the power 2k, minus 1 to the power 2k, this is equal to 1. Always. Always. Whatever be the value of k, doesn't matter. Minus 1 to the power 2k, that will be always 1. Agreed? K could be 1, K could be 2, whatever be that, minus 1 to the power 2K, it will be always 1. Very good. So this will be equal to x of n plus x of n plus n by 2 w. Now 2kn, that I can write wn by 2kn. Is it all right?
Yes.
Okay. So n 2kn, I can take 2 bottom, so I can write wn by 2kn. I hope it's all right. This two,
Yes, sir.
very good. Now I am writing this part, g on of n. Which one is g on of n? X of n, x of n plus n by 2. This part I am writing g on of n. So g on of n, wn by 2 kn, wn by 2 kn. Now g on of n, how many points is there? 0 to n by 2 minus 1. So this is also having at most n by 2 points.
Yes, sir.
1 of n having at most n by 2 point, that is 0 to n by 2 minus 1. 0 to n by 2 minus 1, in between you will be having n by 2 points. Therefore 0 to n by 2 minus 1 g on of n wn by 2 kn, this is essentially n by 2 point dft of g1 of n, which I am writing g1 of k, which is essentially x of 2k, which is essentially x of k, k even. I repeat that g1 of n, this will limit is 0 to n by 2 minus 1, and this is wn by 2. Therefore g1 of k is n by 2 point dft of g1 of n. Agreed? Which is nothing but
Yes.
x of 2k. Agreed? Agreed? I hope it's all right.
Yes.
Now, any doubt if you have in between, then you can ask, not an issue. So we'll, because this is the initial part, we have to understand very clearly. Now moving ahead further, then we are writing g1 of n equal to x of n plus n by 2 for n equal to 0, 1, n by 2 minus 1. This is of course very clear from the summation. The summation is only 0 to n by 2 minus 1, then g1 of n cannot have value beyond that, either side, right? Summation is 0 to n by 2 minus 1. Basically this n will vary 0 to n by 2 minus 1. You cannot have value beyond this limit, which again means that g1 of n equal to x of n plus x of n plus n by 2 for n equal to 0, 1, n by 2 minus 1. I hope it's all right.
Yes.
Agreed? Everybody agrees with that, and so far the derivation is okay?
Yes, sir.
Yes, sir.
Very
Yes,
good.
sir.
Now what I'm writing that g1 of n equal to this for n equal to, all right. Now g1 of k is n by 2 point dft of g1 of n. Everybody agrees with that? Okay. Now next I am writing x of k, k equal to what? That is equal to x of 2k plus 1. Okay, right? X of 2k plus 1 when k equal to what? Now let us see for k. This is also again c, k equal to 1, 2, n by 2 minus 1. This is because x of k endpoint. Then if you took the odd even, so odd even will be distributed equally. So 1 will be 0 to n by 2 minus 1, because even was 0 to n minus 1, odd also will be 0 to n minus 1. Right? Agreed with the argument? Okay? Is it all right? Very good.
Repeat once.
Huh? Repeat. Okay, let me repeat. What I am saying that x of k, if I divide in two parts, odd and even, then you will be having equal number of points over there. Right? Previously, what we have done, when x of n we have divided in two parts, odd even, then 4 points are there in f1 of n, 4 points are there for f2 of n. That is in the idea. Similarly, when x of k is also suppose say n number of points, you could take x of 2k only even part, or x of 2k plus 1 odd part, then odd or even will be having equal number of points. Previously n minus 1, now it will be n by 2 minus 1.
N by 2 minus 1.
Agreed?
Yes.
Now in this expression, I am substituting k equal to 2k plus 1. K equal to 2k plus 1. In this particular expression of x of k, k k equal to 2k plus 1. So if you replace 2k plus 1, this becomes 2k plus 1 and this k becomes 2k plus 1. Therefore, we can say that x of n minus 1 to the power 2k plus 1 wn 2k plus 1 into n. Agreed?
Hmm.
Now, minus 1 to the power 2k plus 1, this will be always negative. Because minus 1 to the power 2k is positive, all right, but minus 1 to the power 1, that will be always negative, is not it? So, this will become x of n minus x of n plus n by 2, all right. Now, wn to kn, wn to kn, that I can write wn by 2 kn, agreed? And that part is wnn, this will remain, okay? This will remain wnn, agreed? Now, if you look at this expression, then this particular term wnn, this is only a function of n, this n, which is variable. Then I have to take this part together with g2 of n. What I am writing now, g2 of n is x of n minus x of n plus n by 2 into wnn. This is together I have to take. This is together I have to take means, why? This is because this term no k involved. There is no involvement of variable k. So this is purely a time function. Therefore, I have to include this within g2 of n. Therefore, my g2 of n will be x of n minus x of n plus n by 2 into wnn. This together is my g2 of n. A point to be noted that g2 of n will be x of n minus x of n plus n by 2 into wnn. And this is wn by 2kn, this is wn by 2kn. This term corresponds to wn 2kn. Therefore, what I am saying that this term is okay here and g2n is here, and here n is varying 0 to n by 2 minus 1. Therefore, and this is n by 2. Therefore, g2 of k, if I write this thing, that will be n by 2 point dft of g2 of n, where g2 of n equal to xn minus x of n plus n by 2 wnn, and this n will vary 0 to n by 2 minus 1. Agreed? Agreed? So what we have
Yes,
done
sir.
so far? So what we have done so far, we have divided x of k into two parts, g1 of k and g2 of k. Of course, we are having corresponding g1 of n and g2 of n. They will be now n by 2 point dft. They are now n by 2 point dft, where x of k is my n point dft. With this process, what I did, I have divided x of k into two parts, or n point dft x of k is now divided into 2 dft of n by 2 points, namely g1 of k and g2 of k. And correspondingly, we are having the expression of g1 of n and g2 of n. g2 of n differs from g1 of n in two respects. One is gn is plus sign and g1 is plus sign and g2 is a negative sign. Not only that, we are having a multiplication factor or phase factor in g2 of n. g2n having additional phase factor, but g1 of n not having additional phase factor. This is the difference between g1 of n, g2 of n. More importantly, they are now n by 2 point sequence instead of n points. X of n is n points. Okay, so J2 of k, G2k is n by 2 point dft of G2 of n. Now let me summarize this thing. X of k n point dft, x of k have from x of k to n by 2 point dft, g1 of k and g2 of k developed, which we did explain. Now from g1 of k, which is n by 2 point dft, to n by 4 point dft, g11 of k and g12 of k will be generated. What I mean? What I did, g1 of k I have developed from x of k. X of k is n point dft, g1 of k is n by 2 point dft. Now from g1 of k, which is a n by 2 point dft, I will generate again two more dfts, that is g11 of k and g12 of k, which will be again g1 of k, k even, g1 of k, k odd. Now these will be d11 of k and d12 of k. They will be 4 n by 4 point dft. Agreed? This will be n by 4 point dft. Similarly, g2 of k, which is n by 2 point dft. Now, to n by 4 point dft, d21 of k and d2 k will be generated. d2 of 1 of k is equal to even part of g2k and g22k is odd part of g2k, and this derivation we will be continue in the next class. So what we have done so far, we are having less than 4 minutes, but before that I would like to conclude the whole thing, that in this particular algorithm what we are trying, I am trying to decompose x of k or decimate x of k into lower order DFTs using frequency domain, discrete frequency domain. So what I have derived today, we have derived two DFT of n by 2 points, which are namely g1 of k and g2 of k from x of k, which is essentially n point DFT. Now what the notion of this algorithm is, suppose you have x of k, n points, then two are g1k, g2k, they are n by 2 points. Now from g1k we are again getting two different decimation. Suppose say d11 of k and d12 of k. So since g1 of k is n by 2 points, then d11 of k and d12 k, if I derive from g1 of k, they will be n by 4 points. Similarly, g2 of k I have derived from x of k n point, g2 of k n by 2 points. Now g2 of k, if I derive two others, right, d21 of k and d22 of k, then they will be having n by 4 points. I hope this is all right so far. Anybody having any doubt, you can ask. Otherwise, I will be having less than 3 minutes left. I would like to conclude. Anybody having any doubts? Any doubts you can ask.
Sir.
No doubts?
Sir. ডিআইটি এফএফটি থেকে ডিআইএফ এফএফটি তে যাচ্ছি, ওটা কোনো কি ড্রব্যাক ছিল তার জন্য এটাতে আসছে না?
না, ওটা কোনো ড্রব্যাকস নাই. This is two different calculations. Right, number of computational complexity, everything will remain same. There is no advantage over, there is a difference between these two algorithms, which I will explain. First difference I have seen, but as far as computational complexity, which is the major target of this algorithm, no difference as such. Okay, they are two different ways of calculation, but everything as far as because main target of this algorithm is to look into the computational complexity, right? So in that way there is no difference. Okay, anything else? Okay. Anything else? Anything else if you have any doubt? No sir. So if it is all right, then I would like to conclude for today. Again we will be meeting tomorrow. Okay, so with this I would conclude today. How many of you attended? I have seen 60. The name Amit, Toritriya, Kea, Anna, Arnav, Sanjana, Akash, Aniket, Anu, Anushka, Arusri, Borun Satpati, Nupur Vishnu, then Shobhashari Chatterjee, Darshana Das, Rajani Kumari. Anybody else other than this? The name I have said, I hope these are the name which I have seen. They are the participants. These are the total participants. All right. Anybody other than this? Then
17 আছে।
Huh?
अरे बाबा सर के लिए
17. I have seen the list. Ami, Toritriya, Kea, Ami, Toritriya, Kea, Ananna, Arnav, Sanjana.
টোটাল 16 জন, আপনি সবারই নাম নিয়ে নিয়েছেন।
Total 16 নাম নিয়ে নিয়েছি।
হ্যাঁ,
আপনাকে বাদ দিয়ে
আপনাকে ছাড়া
17।
আচ্ছা আমাকে ধরলে 17, আমাকে ধরলে 17 তো?
হ্যাঁ স্যার, আপনাকে হ্যাঁ স্যার।
আচ্ছা ঠিক আছে, এখন সব বুঝতে পারছো যা ক্লাসে চলছে বোঝা যাচ্ছে তো?
আচ্ছা
Yes, sir.
ঠিক আছে, ওকে, আই উড লাইক টু কনক্লুড, টাইম ইজ আপ। ওকে, থ্যাংক ইউ।
Thank you, sir.
Thank you,
Sir.
sir.
Thank you, sir.
Thank you, sir.